At first glance, it's just a flat wooden board, something you've probably seen countless times without ever questioning what's inside. But beneath that simple surface is a carefully engineered structure where even a small change can affect how it bends, carries weight, or survives years of use. There's one specific detail in its design that quietly holds everything together, and once you notice it, you start to see it everywhere. So why does plywood almost always have an odd number of layers, and what difference does that actually make in how it performs in real-world conditions? Let's dive into it, right here, on History of Simple Things. Plywood is made by bonding together thin sheets of wood veneer, each carefully peeled from logs and dried to control moisture content before assembly. These sheets are stacked in layers and pressed together using strong adhesives under heat and pressure, forming a rigid and unified panel. What separates plywood from solid wood is not just the layering itself, but how those layers are intentionally arranged. Each veneer is rotated so that its grain runs perpendicular to the one beneath it, creating a cross-laminated structure. This design minimizes the natural weaknesses found in wood, allowing plywood to resist splitting, cracking, and deformation far better than a single solid board. Wood behaves differently depending on which direction you measure it. It expands and contracts far more across the grain than along it, especially when exposed to humidity or temperature changes. This natural movement is what causes solid wood to warp, twist, or even crack over time if it isn't properly managed. By alternating the grain direction in each layer, plywood spreads these movements more evenly throughout the panel instead of letting them build up in one direction. This reduces the chances of visible distortion and helps the material stay flat. This is where the odd number of layers becomes critical. With an odd number, the outermost faces share the same grain direction, allowing the panel to respond consistently to environmental changes instead of creating uneven internal stress between opposing surfaces, which would otherwise lead to gradual bending or instability. A core principle in plywood construction is symmetry. For the panel to remain stable, it needs to be balanced around its center point so that internal forces cancel each other out. This means every layer above the midpoint must have a matching layer below it with the same thickness and grain orientation. An odd number of plies naturally creates a single central core layer that acts as a neutral axis. This balanced structure ensures that tension and compression forces are evenly distributed across the panel. Without this symmetry, the plywood would be more likely to bend, twist, or gradually deform as environmental conditions change over time. If plywood were built with an even number of layers, it would lack a true central core, which disrupts its internal balance. Instead of having a neutral middle layer, the structure would be split between two central plies, making it harder to evenly distribute stress. More importantly, the outer surfaces would end up with grain running in opposite directions. This creates a mismatch in how each face reacts to moisture and temperature. One side may expand or contract slightly more than the other, leading to cupping or warping. Even small imbalances can become noticeable over time, especially in larger panels used in construction or furniture. Plywood is widely used because it provides reliable strength in multiple directions, unlike solid wood, which is strongest along its grain. The cross-laminated structure allows loads to be spread across the entire panel rather than concentrated in one direction. With an odd number of layers, the central ply helps transfer forces between the outer layers, improving the panel's ability to resist bending and shear stress. This makes plywood suitable for demanding applications like flooring, roofing, and wall sheathing. Its predictable performance is one of the main reasons engineers and builders trust it for structural use where consistency matters. From a production standpoint, using an odd number of layers simplifies the process while ensuring consistent results. Manufacturers are able to create balanced panels without needing extra adjustments to compensate for structural weaknesses. Industry standards are built around this method because it reliably produces plywood that performs as expected in real-world conditions. While it is technically possible to produce plywood with an even number of layers, doing so would require additional design considerations to maintain balance, increasing cost and complexity. As a result, odd-numbered constructions have become the standard across nearly all types of plywood products. What makes plywood interesting isn't just that it uses an odd number of layers, but that such a small, almost invisible decision ends up shaping how the entire material behaves. It's a reminder that good design often isn't about adding more, but about arranging things in a way that quietly solves problems before they even appear. The balance built into plywood doesn't draw attention to itself, yet it's the reason the material feels dependable in so many different situations. Once you understand that, it changes how you see it, not as a basic building sheet, but as something carefully thought through, where even the hidden details are doing exactly what they need to do, without ever needing to be noticed. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.